And then we have the sponge. That's C6. It's kind of a sponge. Sponge-like, I would say.
One of the samples you sent to us was a sponge.
Yeah.
You're going to get a pretty big pellet. You're going to have a lot of debris. What we did, what I was going to say, is we split it into 2 reactions. So we did 2 HiC reactions for the sponge, and then we combined them.
At the end?
Yeah.
So
we combined them at the LP, the proximally ligated DNA step. You know, you purify that. So instead of eluting in 100 microliters, we did it in 50 microliters, and then we combined them, and then that's what went into library prep.
Okay. Not just before the library prep.
And I want to say we yielded somewhere around 1,000 nanograms. Well, approximately ligated DNA.
So standard.
Yeah.
So that's
that's definitely going to be standard.
That's from 2 reactions.
From 2 reactions.
All right. I mean, you have worked with that, so there we actually have data.
Yes.
For the sponge, so did you just like grind the tissue directly, or you didn't squeeze out the cells? Okay, because that's what I had to do for DNA isolation. And whenever I try to disrupt the tissue, like we get very damaged DNA.
Oh, really?
Yeah. So what I did was I just soaked the cell, the piece of sponge in EDTA and squeezed out the cells, and then pelleted them, and then thinking maybe cross-linking that. I'm just not sure if we have the equipment to try that.
Squeezing,
That wouldn't be a bad idea, just to compare your results with what we did, because we didn't do that.
Yeah.
Just to see if it looks better.
Do you have any EDTA? I
mean, in our lab,
it's technically it's L1 buffer, but if we don't have time to make that, then we can just use EDTA. It's a high concentration EDTA buffer.
We have EDTA for the TC buffer, so we do that.
That's nice, I can use it because most of the time I just grinded the sample cell squeeze and then I have
for the sponge we didn't do any nuclear isolation. We basically stuck to our normal protocol.
The point is to have EDTA protecting the DNA, and it doesn't affect HiC, right? Like if you have a high concentration of EDTA there.
You're going to do washing anyway, though, so you're going to wash your EDTA because you're going to pellet it, pull that off, and then you're going to add your. Because
basically the idea is just you just soak, you take the tissue, you soak it in this buffer, it will just absorb, and then you can actually work with it, so unfrozen, and then you squeeze it out and centrifuge that to pellet the cells. So I don't know what's it's a trade-off, right, between leaving it frozen and getting the cells out.
You need to calculate the concentration.
So we have another one here. So it's from the same.
I mean that is going to be 100 millimolar.
So we have 0.5. So we just do a 1:5 dilution.
Yeah.
And then use just that, and it's going to be fine.
Great. If that's how you purified your DNA.
How I got the best DNA.
You got the best DNA, then I'd probably stick with that. Like I said, we didn't do it that way. It'd be a good comparison.
Yeah. Because worst case we do have some data, and it should be.
It'd be a good comparison to see if your metrics are better than what we did.
Yeah, because we thought it had maybe something to do with this skeleton, whatever it's made of, that just shears the DNA when you.
Right.
And that will then be done before.
This is basically the tissue grinding procedure, squeeze the water and then centrifuge whatever liquid you get. You can do it in a petri dish or a weighing boat.
Could you help me do this because you've done this before?
We're going to need a petri dish, a weighing boat, just something that we have poured in and then that we can pour into tubes.
And we can actually work on normalize as well.
So right now you're just diluting the
Preparing
EDTA.
the buffer. It's not really the L buffer, but the most important component of this L buffer.
And the reason that you're using the L buffer for the sponge?
So it protects the DNA from degrading or shearing while we handle it.
Okay.
And I saw that helps for DNA isolation, so we're just assuming that it helps for HiC.
All right.
So you're putting
So I'm just doing 100 millimolar, so I'm diluting the EDTA 1 in 5.
Did you take 1 milliliter of the, we will take 1 plus 4
Yeah.
or?
Yeah. Yeah, because probably need around 3 milliliters, or maybe not even.
As long as they're frozen, it doesn't really matter. I mean,
But you do it there or you put it in my machine?
The weighing boats.
And you need to put it on dry ice straight away.
I actually worked at room temperature. I guess we could maybe, with like keeping it on wet ice, just to keep it coldish, maybe be better than working at room temperature. Because this can be done at room temperature for DNA isolation, but maybe.
I was thinking for the rupture, like if we,
No, we don't need to rupture it. So like we soak it in this buffer, and then we take a scalpel blade and chop it up, and then we squeeze the cells out and collect the liquid into Eppendorfs, centrifuge those down, and then we have a cell pellet. So it needs to be non-frozen for this, but maybe ice, like wet ice. Or
excellent.
I'd say probably extracted DNA from the
bigger
size
one?
of one of these.
Yeah,
should
maybe just take the bigger one.
Yeah. Mhm. See how many cells.
And then we can see how many cells we have, and if we don't, we probably are going to have enough.
I mean, anyway, you've done it once, we'll do it once here. I don't think we'll give it another try if this is probably going to be as good as it gets. Because the thing is, like, it yield really a lot of DNA. That was never the issue. It's just like trying to get it non-fragmented. So then we got like, this is the best that we got. Then we still had to do like surgery and like size selection afterwards, but I could yield a tons of DNA. So. When I tried the cryo prep for other disruption methods,
When you did this before, did you actually visualize the cells?
No.
No. But you can see a pellet?
Yeah, definitely see a pellet, and this actually worked quite well because then I used another sponge. So this, like, every working like with this sponge, is like crunchy. Like when you start cutting it, it's very satisfying. The other ones that I worked with was like more of a what you would think like the ones you can buy in souvenir shops to use as actual sponges.
Yeah.
More of a texture like that, and now it's more difficult to work with. Like this is like a nice tissue to work with.
I know when we pulverize it, I didn't actually process the samples, I just kind of oversaw them, but it was very easy to pulverize.
Yeah. Okay. So then I'm just gonna take the bigger of these two pieces. Yeah, or both. And then probably 1 milliliter is gonna be enough here. Just soak it directly. And you see it'll just absorb it, because that's its job. It's already enough, but so we have some liquid to work with. I'll add 1 milliliter.
Okay, it's important that this absorber never stay like without liquid around.
No, like it's good to have some liquid to work with. Like the last time I worked, maybe this is. Thinking maybe we should use all of it because this is quite small compared to what I've used last time, and I mean we're not gonna try more of this sponge, so I think we'll use all of it and make sure we have something to work with rather than keeping two small pieces.
We need to mark the afterwards that the sample ID. Just a reminder.
Yeah.
Just remember that. Happens to concentrate, like forget. If you just moving it around a bit in
I'll
the
just
liquid.
let it, so like basically you want it to defrost while it absorbs the
Yeah, well, that was my
buffer.
second question. That it gets to thaw there.
Yeah,
instead-
yeah, you don't want to let it
Yeah.
thaw before, so
So
that
that
it
no
will in
reactions start happening.
okay. And you could add some more buffer because it's easier to handle than.
Is there something that you're looking for? That it's finished or?
No, I mean it's just like
have water. Yes, do you need it? We're done with ours. Oh, except for the TC buffer.
yeah, you can take it. No, nothing in particular. Okay. Just want to make sure that that the tissue is soaking up the buffer. But yeah, it's a sponge, so you will do that. Here, and then I'm just gonna go with it. Cut it. This part is very satisfying because it's a very crunchy sponge. So you can actually hear the.
Yes, you can leave. Thank you, Chair.
Can you see, Tuuli?
Yeah, okay, good. What sizes of pieces are you aiming for? Just like not finely chopped, but just chop a
No, just
little.
like I find like because the idea is then to squeeze this out, so I don't want to have it too small, but like small enough, maybe something like this. So like, whenever I do something like this, I go for different sizes. So like,
Sorry,
on
Jessica.
average, some will be the perfect size. And then I just want to squeeze these.
Aha, so you like actually squeeze them. It's
Yeah.
not just calling it squeezing.
Yeah, no,
it
it's
is
an
actual
actual
squeezing with the
squeeze.
forceps.
Yeah, so these are not the best forceps for this, so maybe I'll just. So there's the metal ones that are a bit flat at the
Yes.
end. Those are the best ones for this, but these are close enough.
I'm not sure if they're good. Do we have any without?
It's close enough.
I can check because there's another.
I mean, this
Sure.
yield a lot. Like this tissue yields a lot. So even if
Okay.
you don't squeeze it perfectly, I'm sure
Okay, so
you'll
it's
get
good
enough.
enough.
I also even just maybe can someone pass me a spatula and put it here to cool, because maybe that one will work well too.
But I was thinking like maybe for IC was not better to have some inhibitor or something.
What you mean? Sorry.
Like add in the buffer some inhibitor like for proteinase, this stuff for IC. Or do you think that will not affect a lot?
I mean, the idea of the EDTA is that it will protect the DNA.
Okay.
So, I mean, we're just testing here.
Yeah.
I'm
No,
not
it's
sure.
just a
Mhm.
question because I never done it, so.
Is this something you do on? You do this as standard when you're doing DNA extractions on sponges?
I mean, I've done 2 sponges, so if you can call that standard.
No, but I've understood that
Yeah.
it's relatively new.
So this was after the first few attempts that I did, and I didn't get good results. So I just sent Caroline at Detol an email, and she sent me this protocol. That's what they use for sponges. Yeah.
They have
So-
this. But now, if you would get a sponge, this is what you would do.
Yeah.
Yeah, and I think that's a take-home message. If you guys are used to working with a sample, and you have to veer off of the protocol, especially for this, 100% do it.
Then of course we need to centrifuge. I assume we don't have a cooling centrifuge here. Right?
Yes, we do.
Oh.
But it's not cooled, I guess, because today we were going to work in RT, but we do have a cooling centrifuge.
If you, I mean, this we can wait with that it cools, but it also only takes a few minutes. I don't think it's gonna
No, I
be.
think you'll be okay.
Yeah.
Also,
The important thing is that it's in the EDTA now.
So how do you know that you're done? Just experience?
Until the spirit of my ancestors says it's fine. No, I mean, it's just
in the course.
if you feel like nothing is happening anymore,
okay.
then you're sort of done.
But it's not like a texture thing, like it doesn't crunch
They're all
anymore?
I mean, I worked with two sponges and they were different.
Okay.
So like it's just like...
How was this then compared to the other ones?
This is like more crunchy. I mean, there's nice noises when you...
I heard
like,
the noises.
Yeah, when it stops making noises.
Okay, well that's good then.
But then the other one was different, so like...
The other one maybe they became like more small because after a while it was not anymore spongy.
Yeah, maybe. So now I want to collect this. This should be wide enough. Like wide bores would also be an option, but maybe like this will help me get.
we can just clip it.
Yeah, but also like I'll try first because I don't want to get too much debris because like basically what we left behind is the skeleton,
Exactly.
and we
just want the liquid.
Yeah. So a bit of.
Did you have a tube ready? Were
Yeah,
you putting
yeah.
it? Yes. Okay.
Yeah, I have them here in the eyes. So I mean a bit of debris is gonna come with it.
Oh, there. Okay,
Is there such thing as too much squishing?
I don't think so.
Okay.
Even another, you can't just with the scalpel, you can't, or the tweezing, damage anything hard enough, right? Or
Sorry,
at this stage that you can't damage the nuclei in any way.
No, I mean,
with,
so this is a bit more gentle than other disruption method, but I think it's mostly achieved through the EDTA that you don't tear too much of the cells and especially the DNA.
Is he okay there, Pamela?
Yeah.
I mean, of course, there's no guarantee that the nuclei also stay intact with what we're doing, but it's definitely more gentle. Then, because I think this is like a very hard skeleton that they have, and if you just go at it with mechanical disruption, you just start tearing stuff apart. Curious to see how this works.
So we were just discussing, Laura was going to do it in the liquid nitrogen, but what was That's what I was saying, like we can do it however.
Pelleted very well, so I'll just try to.
Some is getting it.
So I wonder if it has a weird consistency, so I'll just try to go with. Now it's coming all wet, so. Or I think maybe we need to spin it out a bit more than this.
But you're discarding the supernatant.
Yeah. They want the cell
keeping the slime. Should it maybe be then spun one more time?
Yeah.
And then either a little longer or can't go that much.
Maybe can we take this width and do it there?
Yeah.
Or can we bring the centrifuge here?
It looks like good sized pellets though.
Yeah, that one is bigger, I think.
We'll see what we're left with after cross-linking.
Yeah. But those should be cells. I mean, of course, squeeze out maybe something else.
Yeah,
as well,
but that should be plenty as well. I mean,
yeah, no, because the yield was never an issue with this species. It's more like the quality that was.
Did we decide in which settings we're using now? We can leave just a longer time, like 1 minute, and the same.
Oh, they're just doing the same again.
Okay. Less ice if you feel it now.
Better this time.
Yeah, it's still quite light of a pebble. More manageable.
And this time it was, sorry, of course was not watching.
It was a bit easier, but there's still quite a bit of liquid, so if this is too much to keep working with, maybe we can spit it down one more time. So remove the
You're gonna do a wash anyway, right?
Before the cross-linking or the... Yeah, true. So then...
You're gonna wash it first and then spin it down, so I think you're okay. You'll dilute out the EDTA.
And I'm thinking to put it back on dry ice until... Because this is going to take a few hours until we cross-link. So maybe... Because I think these pellets you can freeze and then extract DNA afterwards. So I think...
It should be okay for if you get high molecular with DNA from them, so it should be.
I mean, I usually go ahead because it's like a pretty quick transition, but like since we're stopping this for probably 1 or 2 hours now.
I'd probably snap freeze it if you're gonna wait.
So liquid nitrogen and then or just not freeze it.
You just put it in there
Just
to
put
be
on dry
enough.
ice.
Yeah, because it's not that big volumes, so it freezes.
Okay, 1 sample's down. 7 to go.
Pardon?
1 down, 7 to go.
And then of this one we have 2, but we can easily combine it. So I don't know if you want to like split or you just would you do 2 reactions? If we add 500 microliters of PPS in each, and then combine them. Yeah. So I'm transferring this to the other tube so that we all have just 1 tube for this sample. Seems like it's working.
The other one?
Oh, thank you. Seems to be working. Exactly what it all.
If you get stuck to the walls, then it's nicer to have the 200 microliters, so there's not as much area to be covered.
We probably need another one.
Okay, 1.